Welcome to this video, everyone. So what we are going to be talking about now is integrating factors. We are going to be talking about integrating factors. So integrating factors are basically used when we have an ODE that looks in this form: y prime plus p of y equals to, let's say, r of x. Whenever you see an equation that looks like this, an ODE that looks like this, you are going to use an integrating factor. So how do you know? You have your y prime, your dy dx, you have your y, then on this side we have an r of x, and r of x is the any function that is on any function of x that you can take to this other side. For example, look at this now. We have our y prime, we have our p of y. Our p of y is -1 equals to this our r of x. And for here we have our y prime, this is our p of y, our p of x, this is our p, py is, so p is tan x equals to this our r of x. So integrating factor is integrating factor, I write integrating factor as 1 of x equals to e raised to power, this p, you integrate it, p dx. So I can call it my integrating factor, if. So whenever you have an equation like this, your integrating factor is, you look for your p first. Look for your p, then p is always the coefficient of y, so you integrate it in this format, and the only thing you just need to remember is e raised power integral of p dx, and this is our integrating factor. So now let's solve questions 1 and 2 using integrating factors. Question number 1, we have y prime minus y equals to 1 minus x. So this means our p, which is a function of x, is what? -1, is a constant. So don't let me say p, which is a function of x. Our p is -1. So our integrating factor if equals to e raised power integral of -1 dx. Abi? And this is going to give us what? E raised power minus x. We are now adding plus c. This is our integrating factor. So what do? After we have gotten our integrating factor, we are going to multiply the whole equation through by this integrating factor. We are going to do ODE times the integrating factor. The integrating factor is this 1 of x. So let's continue. Multiplying through this equation, using this, we are going to have e raised power minus x y prime minus e raised power minus x y equals to e raised power minus x into bracket 1 minus x. So after using your integrating factor, there's only one thing you need to notice. If you compare these two, if you look at these two, you are going to find that it is the same thing as the integrating factor, and y is the differential of the integrating factor and your dependent variable. Look at this. If I differentiate e minus x, it gives me minus e minus x, right? If I differentiate y, it gives me y prime. So it means I have differentiated this, and that's what gave me this. This is the differential of this. If you understand what I'm saying. Yeah, after using your integrating factor, your answer for this side, your integral of this side, will look in this format. Like your format, the format of the part of this this right hand side, your whatever hand side is this. So the of this equals to e minus x into bracket 1 minus x. So what does this mean? It means we are going to integrate both sides. The differentiation of this will give us this. So we have to integrate both sides. So integrate. If we integrate this side, we get e minus x and y equals to integral of e minus x e minus x dx. So we are integrating, I have integrated this side, and this is what it gives me. This is what it gives me. So we are going to integrate this side too. So it means e minus xy equals to integrate e minus x, you get minus e minus x minus integral of x dot e minus x dx. Now this is where we are going to use integration by parts. I will not advise us to use the I method. Let's use integration by parts. Let me just clean this side a bit. So we want to integrate x dot e raised power minus x dx. for the sake of those that would like us to work out on integration by parts using step-by-step process, we use our LIATE, which shows that our algebraic functions comes before our exponential function. So we are taking this as our u, and this as our dv. U equals to x, which means du equals to the x. dv equals to e minus x dx. Integrating both sides, you have v equals to what? Minus e minus x. So the formula for integrating by part is u dv equals to uv minus integral of v du. So after integrating this side, I'm going to have e minus xy equals to minus e minus x minus, now let's integrate this side. Uv, what was uv? U is x. What was v? Minus e minus x minus integral of what was v? My v is minus, which means it can turn this one to plus. I'm bringing the minus out. It can turn this one to plus. My v is e minus x. What's my du? Du is dx. So if I integrate this one, it's going to become minus x e minus x minus, if I integrate this, I get minus e minus x. So I can write this down into this place again. Minus, since minus is multiplying through this has to turn to plus x e minus x plus e minus x plus c. Now, if you look at this, you are going to notice that this minus e minus x, this plus e minus x, both of them cancel out. So it means e minus xy equals to x e minus x plus c, right? So what do we do now? We make y the subject of the formula. How do we make y the subject of the formula? We divide through by whatever is in front of y. We divide through by whatever is in front of y, which is e minus x. But if you notice this, you are going to see this e minus, okay, let me write it as this. Y over e raised to power x equals to, right, x over e raised to power x plus c. E minus x is the same thing as e raised to over e raised to power x. So I multiply through by e raised to power x. So I have e raised to power x dot y over e raised to power x equals to e raised to power x dot x over e raised to power x plus e raised to power x dot c. I multiply through by e raised to power x, which means these ones cancel out on this side. Y equals to e raised to power x cancel out on this side too. C and x plus c e raised to power x. And this is our final answer. So this is the answer to the first using integrating factors. This is the first answer for the first ODE. This is the final answer for the first ODE. Now let's solve question 2. Let's solve the second one using integrating factors. Using integrating factors. The second one now, we first have to identify our p of x. Don't forget, our integrating factor 1 of x is equal to e raised to power integral of p dx. So the first thing you have to identify is your p. What is p? In this function, our p which is function of x is tan x. P equals to tan x is the one in front of y. So it means our integrating factor if equals to e raised to power integral of tan x dx. E raised to power integral of tan x dx. Now, when we integrate tan x, what are we going to get? We are going to get minus ln cos x, which is the same thing as is equivalent to ln sec x. Don't forget that cos x, this is minus cos x. If minus comes to the other side, it becomes 1 over cos x is the same thing as sec x. So both of them are what? Equivalent. So I would prefer to use this, or let's use both of them and we see we get to the same answer. So we are using e minus ln cos x, and we said it is equivalent to what? E raised to power ln sec x, which basically means if this cancels out, our answer is supposed to be sec x. Our integrating factor should be sec x. Look at this one. Minus will go to the other side and we have e raised to power ln cos x minus 1, right? This one will cancel out and we have 1 over cos x. 1 over cos x is the same thing as sec x, which means sec x and sec x is our integrating factor. Our integrating factor is therefore e raised to power integral of tan x dx, which equals to what? Sec x. We are now adding our plus c. We don't need it since this is just an integrating factor. Now let's work out the solution to the question using the integrating factor. Question number 2 now. Continue. after we have gotten our integrating factor, the next thing we are going to do is what? Multiply this whole ODE through by the integrating factor. We multiply it through. So we are going to have something like y prime sec x and multiplying through by sec x plus y sec x tan x equals to now sin x sec x. If we multiply it, don't forget sec x is 1 over cos x. So if I do sin x sec x, which is sin x over cos x, is the same thing as saying tan x. The same thing as saying tan x equals to tan x. Now, what do we do after we have gotten this? You have to notice that this your left side. If we differentiate y, we get y prime is here. If we differentiate sec x, we get sec x tan x, it is here. So it means this is the same thing as writing differential of y sec x. If we differentiate this one using product rule, we have y dy dx, y turns to dy dx and sec x plus using product rule. Differentiate sec x, we get sec x tan x and this y equals to what? Equals to tan x. So this is the differential of this. So after having something like this, the y sec x equals to tan x, what do? We integrate both sides with respect to x. Or with respect to anything. So if we integrate this side with respect to x, we are going to get y sec x equals to what? Integral of tan x dx. We have done this before. The integral of tan x is what? Ln sec x plus c. We are going to add our constant of integration here, please. Ln sec x plus c or minus ln cos x, anyone you wish to use. It's the same thing as minus ln cos x plus c. So it means we have to isolate our y, make y separate formula, which means we are multiplying through by cos x or we are dividing through by sec x. If we divide through by sec x, it's the same thing as saying we multiply through by cos x. So y equals to, let's multiply through by cos x. Y sec x times cos x is 1. So multiplying through by cos x, we have y equals to cos x ln sec x plus c cos x, or is equal to minus cos x ln cos x plus c cos x, and this is our final answer. Pick either of the two, or I can write it as y equals to cos x into bracket ln sec x plus 1 is equal to what? Cos x into bracket, I can bring this one first, c minus ln cos x, and that's the final answer to the second ODE using integrating factor. And this this is plus c. Cos x into bracket, if we factors cos x out, we are going to get this. Yes. So, and this brings us to the end of this tutorial on integrating factors. So don't forget to like, to share, and subscribe to the channel, please. You can also share this video to your loved ones, to your friends. Please let them also gain in this knowledge. Thank you.